Bismillahirrahmanirrahim. In this video, we'll be discussing example 4.8 from EDC's book by Mr. Bolstead. And the topic is the voltage divider bias configuration. Now, earlier we have done what is called the emitter bias configuration. See this one. And there were a comparison made in example 4.5 that if we change beta from 50 to 100, you can see the IV current changes, similarly IC current changes, similarly VCE, the collector emitter voltage also changes. So this is not very desirable. It would be desirable to develop a bias circuit that is less dependent on the transistor beta. And so for this, a voltage division circuit was used. So this is the voltage division circuit. You can see the voltage at the base is being used by divide voltage division rule, or by dividing between two resistors. That is why it is called the voltage divider bias. Now, as we have earlier also discussed that for DC analysis, we remove the capacitor. So like this, we have done it here, remove the capacitor. And then if we compare it with the emitter bias circuit, we need something, some voltage here. And as I mentioned, that we'll get that by means of a voltage division rule. Or actually, we'll be applying the Thevenin's theorem to get the voltage at this point and also the resistance at this point. So E Thevenin or V Thevenin will obtain, and similarly R Thevenin will obtain at this point. For this, we are just removing separating the two VCCs, so it will become easy to find the V Thevenin and R Thevenin from the left branch. And now you can see we are interested in this voltage, that means the voltage across resistor R2. This voltage will be called E Thevenin or VR Thevenin, and the voltage division rule says that the total voltage, that is VCC, divided by total resistance multiplied by the resistance across which we want to find the voltage, so multiplied by R2. We'll use this formula. And now for R Thevenin, I hope you recall that for R Thevenin, we short circuit the source. So voltage source is grounded, and therefore if you look carefully, R1 and R2, they are in parallel because this is ground, so these two will come in parallel. So we'll solve them in parallel to find the R Thevenin. Okay, with this background, let's see the question. We have to determine the DC bias voltage VCE, that was the collector emitter voltage we have to find, and the current IC, that is the collector current IC. So as we discussed, we first of all remove the capacitors, and then I have also added the name R1, R2 is not given here. I have given R1, R2, RC, RE, and also separated the the voltage source into two branches. Okay, so now if we use the Thevenin, then we'll have a voltage source and we'll have a resistance connected to the base. So all we need to find is, first of all, E Thevenin and R Thevenin. We have already learned the formula for E Thevenin, which is R2 VC divided by R1, R2. So just plug in the values and the answer will be 2 volts. So this voltage will be 2 volts. And now R Thevenin, we have learned that they can be solved in parallel. So R1, R2 in parallel, and putting in the values, these two values, the answer will be 3.55 kilo ohm. So this is 3.55 kilo. Now we'll use this circuit to find the parameters. First we'll try to find parameter IC, but for that, because we know that IC is equal to beta times IB, so if we can find IB, we can easily find IC. And IB we can find from this loop here. So by writing KVL, we start from here minus E Thevenin, then plus IBRB, plus VBE, and plus IERE. Now, because we want to find IB, we'll substitute IE with IB. So IE can be written as beta plus 1 times IB. We'll put this value here. So we get beta plus 1 IBRE, and then we'll just rearrange the voltages on the right hand side and these the left hand side, taking common I. And now for IB, we can write this equation. So this divided by this whole thing. And now we'll plug in the values. So V Thevenin is 2 volt. VBE, we know for the transistor, it is 0.7 volt. And then the resistances, beta plus 1 will be 100 plus 1, because beta is 100. So 100 plus 1 will be 101. RE is 1.5 kilo, not visible here, but it is 1.5 kilo. And then solving further, IB is 8.38 microampere. IB we have found. Now we'll use this formula to find IC. So beta times IB, beta is 100 times IB. So IC is 0.84 milliampere. So the first part we have done. Now let's go to the second part to find VCE. This is VCE. So we'll write the equation directly now. So we know that the VCC can be divided into these 3 parts. So VCC is equal to, drop here ICRC, drop in VCE, and drop in IERE. So ICRC plus VCE plus IERE. Now here also we'll replace IE, because we know the value of IC, and we also know that IE is approximately equal to IC. So replacing IE by IC and just manipulating, we need to find VCE. So VCE will be VCC minus ICRC and ICRE. Plugging in the values, VCE will be 12.34 volt. So this is an easy question. I hope you have been able to follow. Thank you.